Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video I will attempt to predict or classify if a person would default or fail to make required payments on their credit card debt. Now I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So to get started writing this code, go ahead and click on File, then New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. Also, you can get the code or data set or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. So the first thing that I'm going to do is put in some comments. I'm going to put in a description about the program. So I'm just going to type here, use machine learning to predict if a person will default on their credit card debt. All right. So before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button. And to be notified about new videos from this channel, hit that bell notification. Also, the material in this video is purely educational and should not be taken as professional finance advice. All right. So let's go ahead and create a new cell by clicking this code button in the top left. And we need to install a few packages. So the first thing that I'm going to do is install a package called PyCaret. So just type pip and then install PyCaret, and go ahead and run this by clicking this button here to the left. And what I'm going to do is I'm going to pause the video while this package installs. That way it's quicker for you. And then I'm going to unpause the video and come back when it's finished. So I'll see you soon. Okay, so I'm back and the package is done installing. So let's go ahead and create a new cell, and I see I need to restart the runtime here, so I'm just going to go ahead and click on restart runtime, click yes. Okay, so there we go. So next I'm going to install markup safe. So I'm just going to type pip install markup safe, and I'm going to put 2 equal signs and then put 2.0.1. so let's go ahead and run this to install markup safe 2.0.1, and it's done. All right, so I'm going to create a new cell and install one more package. So I'm going to type pip install, and I'm going to install Jinja 2. All right, so let's go ahead and run this, and this should take a small amount of time, and it's done. So it looks like it's installed. So I'm done installing the packages that I need for this program. All right, so let's create a new cell, and now let's import the libraries that I'm going to be using for the program. So I'm going to import Jinja 2, and I'm going to import pandas as PD. All right, so let's go ahead and run this. Okay, let's create a new cell. All right, so next I need to load the data that I plan on using throughout the program. So to do this, I need to use Google's library. So from google.colab, I'm going to import files, and I'm going to type files.upload to upload the file to Google Colab. So let's click on choose files, and I'm going to choose this credit.csv file that I have, and it's uploading right now. All right, so this file contains information on individuals about whether or not they defaulted on their credit card loan or not, right? So I think I said that, whether or not they defaulted on their credit card loans. So let's take a look at that data. So I'm going to create a new cell now that the data is done uploading to Google Colab. So I need to read in the data. So I'm going to create a variable called data set, and I'm going to set this equal to pd.read_csv. And I'm going to put in the name of that data set, which is called credit.csv, and then I want to show the data. So I'm just going to type data set here to take a look at it. Let's go ahead and run this cell, and now we can see the data set. So this data set contains 25 columns and 24,000 rows of data. Okay, so this column here, limit BAL, is the amount of given credit in NT dollars. Sex will be male or female, 1 meaning male, 2 meaning female. Education is that person's educational level, whether that's graduate school, which is signified by the number or represented by the number 1, and or a university, which is represented by the number 2, or high school, which is represented by the number 3, or other, which is represented by the number 4, or unknown, which is represented by the number 5 or 6, I believe. All right. And then also we have that person's marriage status, so, or marital status. So are they married? If they're married, then we'll see a value of 1. If they're single, we'll see a value of 2. And then for other, we'll see a value of 3. And then it has the person's age, which is of course just their age in years. And then we have a column called pay underscore 1. Well, here any column that has pay is meant to represent the repayment status for that person. So it's going to be the repayment status in months ago. So for example, pay underscore 1 means repayment 1 month ago. Pay underscore 2 means repayment 2 months ago, and so on and so forth. All right. And then we scroll over here and we can see the bill amount, right, which is the, well, bill amount. So we have bill underscore amount, and then we have a number which tells us the bill statement in months ago. So here I have bill underscore amount 4, and this tells me the bill statement 4 months ago. And here I have the bill amount 5, so this tells me the bill statement 5 months ago, and so on and so forth. All right. And then next we have pay amount 1, or pay AMT 1, right? And so what this is the amount of payment that the individual gave in months ago. So pay underscore amount 1 would be the amount of payment 1 month ago. All right. And then pay amount 2 would be the amount of payment 2 months ago. Okay. So I think that's understandable. And then over here we have the target variable, which tells us if this person defaulted on their credit card debt or not. So a 1 means yes, they did, and a 0 means no, they didn't. So this is a binary classification problem in machine learning. All right. So I think that we got all of that out the way. Let's go ahead and create a new cell. All right. And now in this cell, what I plan on doing, well, one, I want to kind of just see the column. So what I'm going to do is I'm going to put data set dot columns. I'm going to just run this, and I want to get rid of this unnamed column. So I'm going to type data set dot drop, and I want to drop that unnamed 0 column. Let's see what we get. Need to add an axis. So axis equals 1. Let's take a look now. Okay, perfect. So what I'm going to do here is I'm going to set data set equal to data set dot drop unnamed 0, because that column unnamed 0 here isn't important. It's just the indices here to the left. All right. So I'm going to go ahead and get rid of that in the data set. So let's just show the data set here. So here I'm just showing the columns, and I can really get rid of this now, right? I don't even need it. I don't need it, so I'm just going to get rid of it. So here what we're really doing is dropping the unnamed 0 column. Okay, and then I'm just going to show the new data set. All right, so let's go ahead and run this. All right, so there we go. So now we have 24 columns and 24,000 rows of data. Okay, so let's go ahead and create a new cell. And what I want to do is I want to use 90% of the data to train on. And then I want to use 10% of the data to test on, to test the model that we're going to create on. So here I'm going to type in 10% of the data to test on, which will be data the model has not seen before. Okay, so I'm going to create a variable called train underscore data. I'm going to set it equal to our data set dot sample, and I want to sample 90%. So I'm going to put, or set equal to frac, I'm going to put 0.90, and then I'm going to give this a random state. So the random state will be 1, 2, 3, or maybe I go with, let's go with 3, 4, 5. Okay, so that's going to be the random state. And then I'm going to create the test data. So I'm going to create a variable called test underscore data and set it equal to data set dot drop, and I want to drop train underscore data dot index. Okay, so we're going to remove from the data set, we're going to remove all of the train data. All right, and that will only leave the data that we want to test on, the test data. Okay, all right, so now that we're done doing that, we need to reset the index for both of these data sets. So train underscore data dot reset underscore index in place will be true, so we want it to reset the index, and then drop would equal true as well, so we want it to drop. All right, and I want to do the same thing for test data. So test data dot reset underscore index in place equal to true, and then drop equal to true. Okay, all right, so let's go ahead and run this. It looks good. I'm going to create a new cell now that we have our 2 new data sets, right? And now I want to print the number of rows and columns of the new data sets. So they should add up to the same number of rows in our data set, right, which is 24,000 rows of data, and they both should still have 24 columns. So let's create a print statement here. I'm going to put data used to train the model has, and I'm going to put a string here. So I'm going to already cast this as a string, and that's what str left parentheses right parentheses mean. It's just a function to cast whatever I put in there to a string. All right, so I'm going to put train underscore data dot shape at position 0. So that will be the row. And so I'm going to put a plus sign here to append this string rows, and another plus sign to get the column. So I'm going to cast train data dot shape at position 1 as a string, and then I'm going to put a plus sign to append columns. Okay, so I think that looks good. Let's go ahead and just run this to make sure. So now we can see that the data used to train the model has 21,600 rows and 24 columns, and I want to put a space right here. So let's run this again, and that looks a lot better. Okay, and then I'm going to just highlight this. I'm going to copy using Control C, and I'm going to come down here and paste it using Control V and change a few things. So here I'm going to put unseen data, which is really the test data, right? So I'm going to put AKA test data for making predictions or classifications has, well, now we need to change this to be test data instead of train data. Test underscore data shape at position 0, which will be the rows, and test underscore data at position, test underscore data dot shape at position 1, which will be the columns. And test underscore data dot shape at position 0 will be the rows. So let's go ahead and run this. Okay, so now we can see unseen data, aka test data for making predictions or classifications, has 2,400 rows and 24,000 columns. So if we add these two rows together, we get 24,000, which will be the same number of rows in our data set. So that's good. All right, so let's go ahead and create a new cell. And now I need to import another library. So from PyCaret dot classification, I want to import everything. So import star. I'm going to create a variable called s, and I'm going to set it equal to setup, and I need to tell it what data to input or to set up. So that's going to be the train underscore data, and then I need to tell it the target variable, which is what we want to determine or classify. So in this case, it's the default column. So here I'm going to put default, and then we need to give it a session ID, and I'm going to choose 345 for the session ID. So let's go ahead and run this, and this may actually take a little bit of time to set up. Okay, so the interesting thing about this setup function is that it gives us this nice chart here, right? So we can see that limit val, that column is numeric, sex is categorical, education is categorical, data type, and age is numeric. So we can see all this information about our data set, and of course default, which is our target variable, is the label. So here I'm just going to press enter, and now let me scroll up a little bit. It gives us even more information. So it tells us the session ID is 345, which is a pseudo random number distributed as a seed in all functions for later reproducibility. And then it tells us what our target variable is, which is the default column. And then it tells us our target type. So in this case, our target type is 1 or 0, so it's binary. However, it could have also been multi-class, right, if it was more than 2. Okay, and then it tells us if our data is label encoded, and for this data set, no label encoding was required because the variable types were all numeric, right? They're all numbers in the data set. Okay, and it tells us the number of rows and columns for this data set, which we saw earlier up here is 21,600 rows and 24 columns. It tells us if our data set is missing any values. So false means that it's not, and of course true would mean that it is missing some values. It tells us the number of features. So we have 14 features, 14 numeric features, and then 9 categorical features, right? So we have 23 features in total, and that makes sense because we have 24 columns. If we subtract 1 column for the target variable, that will leave 23, and 14 plus 9 is 23. Okay, so I think that's pretty good. They also have, let's see here, we got fold numbers, USI, basically a lot of information about our data here. Okay. All right, so let me just move on. Okay, so let's create a new cell. Now that we've initialized the setup, and what I want to do is I want to create, or not create, I want to compare multiple models. All right, so here we're going to just compare models. All right, so to do that, we could use a function called compare underscore models. And I'm going to set this equal to model. So I'm going to create a variable called model and set it equal to compare models. And let's run this. And so what this will do is this will allow us to compare metrics from different models. Okay, so it's going to create this nice grid for us. So right now it's looking and loading all these different models. So we can see the model's accuracy. We can see the AUC, the area under the curve. We can see the recall, the PREC, P-R-E-C, the precision. We can see the F1 score. We can see the kappa, and we can see the MCC. So this looks pretty good, and we can see the model name, right? So we can see rich classifier, logistic regression, k-neighbors classifier, so on and so forth. All right, and what this is going to do is it's going to order them by the accuracy. So the model with the best accuracy will be the first row. All right, so let's let it finish. And I'm going to just pause the video while it does its thing and then unpause it when it's done. Okay, so it looks like it's done, and we can see the model that gave us the highest accuracy is the gradient boosting classifier. So that's pretty cool. And that's the model that's stored here, okay, in our variable called model. But just for fun, I'm going to show you all how you can choose really any model here to test your data on. So let's go ahead and choose the random forest classifier. So it has an accuracy of about 81.65%, which is decent. And we're going to use this RF variable to get this model. All right, so, or to create the model. So let's go ahead and let's create the random forest model. All right, so I'm going to create a variable called forest and set it equal to create underscore model, and I'm going to put RF, and then I'm going to just run this, and this should create that random forest model for us. So let's just give it some time. Okay, and so it's done, and we can see the model's average here, right? So the average accuracy, the average AUC, the average recall, all that's right here, and this should match what we saw up here. So let's just take a look. Let me take this average here is 81.65% accuracy, and if we look at that random forest model, we can see 81.65% accuracy, and then the AUC is 76.79%. So let's look down here and we see 76.79%. All right, so it's just taking the average of the folds. All right, so now we have our model created and stored in forest. Let's go ahead and create a new cell, and let me show you some interesting things about this PyCaret package. All right, so next thing I'm going to do is I'm going to plot the model. So I'm going to tell it what model to plot, which is the forest model that we just created. And I'm going to tell it what type of plot. So I'm going to set plot equal to confusion underscore matrix. All right, so let's go ahead and run this. Okay, and now we get this nice confusion matrix. So we can see the true negative, we can see the false positives, the false negatives, and the true positives, right? So the true class on the left here on the y-axis, and then the predicted class on the x-axis. So that's pretty cool. All right, let's create a new cell, let's plot something else. So here we just we plot the confusion matrix. So next, let's plot the feature importance. All right, so I'm just going to say plot model again, plot underscore model, and I'm going to tell it what model, forest, and then plot equal to feature. All right, so let's go ahead and run this. And there we go. We can see the feature importance, and of course, feature importance assigns the score of input features based on their importance to predict the output. So basically this means that the higher that score is, the more important, or let me see here, another way of saying it, the more that feature will be responsible for predicting the output. Okay, so for instance here, age seems to be the most important feature in this data set, followed by limit val. Okay, all right, so let's go ahead and create a new cell, and here I want to evaluate the model. So this will just give us another way of evaluating our model. So here I'm going to say evaluate underscore model forest, and that should be it actually. So let's go ahead and run this, and what you can see here is we have some options now. So you can see that we have confusion matrix here. So if I just click that, you'll see that it loads up that confusion matrix that we created earlier, which is pretty cool. So it has all of these different plots that we can use to evaluate our model. So all these different options that you can select. Okay, so let's create a new cell. And now finally, let's show the model's predictions on the test data. So that's the data that is never seen before. Let's see how good it is. So I'm going to create a variable called predictions, and I'm going to set it equal to predict underscore model, and I'm going to put in the forest model, and I'm going to set data equal to test underscore data. So that's our test data, and then I'm going to type predictions just to kind of see what it looks like. So we're going to show the predictions. Let's go ahead and run this. Okay, so here we can see the model's metrics on the test data. So now we can see that the accuracy is a little bit lower than on the training data, right? So now we get an 80.92% accuracy. Let's go ahead and scroll over. Okay, so now we can see the default column, which tells us if that person defaulted on their credit card debt or not. So again, a value of 0 means no default payment, and then a value of 1 means yes, there was a default payment. So this is what actually happened, and the label is what our model predicts happened, or it predicts or classifies that person as defaulting on their credit card debt. Okay, and then that's the score of how confident it is about its label. So here we can see that this person got a 1, so yes, they had a default payment, and the label is 0. So the model thought that they did not, and indeed they did. And then we see that the model got it correct in these 3 rows. Looks like the model was incorrect here, and the model was incorrect here. So the model seems okay, right? I'm not really sure if the model is just, you know, guessing zeros. Well, it's not just guessing zeros, but I'm not sure if just guessing 0 would be just as accurate as this model or not. All right, so let's go ahead and create a new cell. And now I'm going to show you all how to save this model. So save the model, and that's simple enough. Just use the save model function, put in the model, and then put in the name for the model. So I'm going to call it random forest model. I'm going to run this. Okay, so it saved the data. If I come over here to my files, I can now see that saved data here called random forest model.pkl. Okay, I'm going to create a new cell, and I'm going to now show you how to load the saved model. So I'm going to create a variable called saved underscore forest, and I'm going to set it equal to load underscore model, and I'm going to load random forest model. Okay, so let's run this. So now the data is loaded successfully, and now I want to make a prediction or classification using the saved model. So I'm going to create a variable called saved underscore model underscore prediction and set it equal to predict underscore model. We're going to put in saved underscore forest, and then the data will be the test data that we used before. And I'm going to type saved underscore model underscore prediction dot head, and I only want to see the first 8 rows of data. So let's go ahead and run this, and everything should be the same like before. So we can see the accuracy is still the same, the AUC is still the same. Let's scroll over. Okay, and we can see that we're getting the same predictions as well. So again, it does kind of seem like the label, at least here, is just choosing zeros, but from what we saw before, it's not just choosing zeros, because we can see a 1 here, and I'm not really sure if just choosing 0 would make this model more accurate or not, right? So that would not be a good thing if it did. But that's basically it. That's the end of the video. Thanks for watching, and thank you to the supporters supporting this channel on patreon.com/computerscience. Again, if you would like to be a supporter on patreon.com/computerscience, I will leave a link in the description below for that. Thanks for watching, and I hope you all have a great day, and I will see you in the next video.